Namaste everyone. I, Shailendra, welcome you to Monastic online classes. I am a mathematics teacher. Today I will going to tell something about geometry, first chapter, that is area of quadrilateral and parallelograms. For the SEE students in geometry, the first exercise we have quadrilateral and its areas. In this exercise, we have three important theorems. Generally, in SEE, either the theorem will be asked from this chapter or from the circle. In this exercise, we have three theorems. First theorem is parallelograms standing on the same base and between the same parallel lines. Are equal in area. This theorem will be solved in three ways. We have to take care on each of them. First, we have to draw the appropriate figure, naming ourselves. We have taken base and parallel lines. In this figure, PQ is the base and PQ and RS are two parallel lines. Between these two, we have to draw two parallelograms. These are the two parallelograms. These arrows shows the parallel lines. And now from the figure we can see there are two parallelograms. First parallelogram is PQUR and second one is PQST. As you know, in theorem we always have to start with figure, then we have to write the given. Here in given, we have to name the parallelograms. Parallelograms PQUR and PQST are standing on the same base PQ and between the parallel lines PQ and RS. We will start generally in given with the name of the parallelogram. From the figure and by the arrows we can clearly see what's the name of the parallelogram is PQUR and PQST. There are two parallelograms. They are standing on the same base PQ and between the two parallel lines PQ and RS. We have to prove area of parallelogram PQUR equal area of parallelogram PQST. There are many ways in SEE. This question has been asked in two ways. In one, you must have to show these two triangles congruent. Then you have to prove these areas are equal. In such cases, we have only one option. So we will do the first option first. In this, we don't need the construction. Then we have to go on proof. Then after proof, you have statements and regions. The first of all, as I have said you have to show these two triangles congruent. The name of the triangle is PTR and QSU. Here in these two triangles, we can see these two lines are parallel, so these two are corresponding angles. Again, these two lines are parallel, so these two angles are again corresponding angles. And one of the opposite side, either we can take PR and QU or PT and QS. So using angle side, we can prove these two triangles congruent. Angle PRT equal angle QUS, that is angle. Reason is being corresponding angles. We can write the reason of that, but it will be better if you write on which line PR parallel with QU. Again, angle PTR is equal with angle QSU. That's the same region, corresponding angle, being corresponding angles on line PT parallel to QS. And the third one is PR equal to QU side being opposite sides of a parallel. So now we have proved these two triangles are congruent. Statements, regions, that's the second one. Triangle PTR congruent with triangle QSU. Reason is by angle side axiom. One of the properties of congruent triangles is they are equal in areas. So we can write area of triangle PTR equals area of triangle QSU, that is being areas of congruent triangles. Now finally, in this figure, you can see this figure. That's a trapezium because these two sides are parallel. So adding this common side to both of these triangles, we will get to our result. It means we can say this trapezium means PQUT. And now area of triangle PTR plus area of trapezium PQUT equal area of triangle QSU plus area of trapezium PQUT. Adding area of trapezium PQUT on both sides of statement 3. That's our result. If you add these two, that's parallelogram. Area of parallelogram PQUR is equal to area of parallelogram PQST. That's from statement 4. In this way, we have completed our first theorem. This theorem, some changes can be done. Exactly the same thing, but the figure can be changed. Suppose if the figure is now drawn in this way, what's the changes you can see in the previous figure and this figure? If you look it nicely, you will find earlier these two lines are not intersecting each other, but now these two lines are intersecting each other. So in this question, up to 3 number, there will be no changes because we have done exactly the same thing, naming are same. But after this, from this whole trapezium, if we subtract this part, we will get this parallelogram, and subtracting this, we will get the another, that is PQUR. When in exam already figures are drawn, then you have to know in both ways how can you solve this question. Then I have said earlier, we can do this question in many ways. That's one of the way when it is already asked you, first prove these two triangles congruent, then prove the parallelograms area are equal. That's nice. In alternative method, the easiest way which we can do in this question is we have to do a construction. In construction, ways that will be the easiest for us to do such question. If we draw a perpendicular given and to prove is exactly the same as earlier, changing from construction. In this figure we have drawn TA perpendicular to PQ is drawn. Now, using the formula of area of a parallelogram, you know that area of a parallelogram is base into height. And here in both these parallelogram base are same PQ. And one more thing, that is, you know that the perpendicular distance between two parallel lines are always the same. It means TA is height for both these parallelograms. So now using this area of parallelogram PQTR equal PQ into TA. Region is area of a parallelogram is equal to base into height. Again, area of parallelogram PQSU equal PQ into TA, same as region 1. Region 1. Third, area of parallelogram PQTR equal area of parallelogram PQSU from statement 1 and 2. That's proof completed. In this way you can complete the first theorem. Now going to the second one. Theorem second. Area of a triangle is half the area of a parallelogram. Standing on the same base and between the same parallel lines. In theorem 2, same as theorem first, we will start the figure with first taking the base, naming the base, then the two parallel lines. Here we have the base name is KL and two parallel lines are KL and PQ. On this base we have a triangle and we have a parallelogram. Now in this figure you can see a triangle PKL and parallelogram KLQT. We have to prove area of triangle is half the area of a parallelogram. Starting with the given, we will start same as earlier. First of all, it is triangle. In this figure, triangle name is PKL and parallelogram is KLQT are standing on the same base, and in this figure base is KL and between the same parallel lines they are KL and PQ. We have to prove area of triangle PKL is equal to half the area of parallelogram KLQT. One of the way we have to do the construction, we will draw a parallel line from L which will be parallel with line LP. If we draw a line LA which is parallel with KP, then our construction is LA parallel with KP is drawn. Now in this figure what we can see, there are two parallelograms. We have already one parallelogram, its name KLQT. And after the construction, we have completed another parallelogram, that is KLAP. In previous theorem, we have learned area of parallelograms standing on the same base and between same parallel lines are equal. So area of these two parallelograms became equal. And one of the properties of parallelogram is each diagonal bisect of parallelogram into two equal areas. So using that we can complete this theorem. First starting with this parallelogram KLAP. Not necessary we have to write parallelogram KLAP is a parallelogram. Then we have to do this. We can do that directly. And in this parallelogram, diagonal name is PL. So we can write area of triangle PKL, we have named PKL equal half the area of parallelogram KLAP. The region is diagonal bisects of parallelogram. And first theorem, we have learned areas of two parallelograms are equal when they are standing on the same base and between same parallel lines. Here we have two parallelograms. First one is KLAP. Then we have another one, that is KLQT. Both are equal in areas. Area, we will write same as earlier theorem, parallelograms standing on the same base and between the same parallel lines are equal in area. Now here we have KLAP and this is equal with KLQT. So we can replace this KLAP with KLQT. Therefore, area of triangle PKL equal half the area of parallelogram KLQT, that is from statement 1 and 2. We have completed the second theorem in this way. In another way, same as earlier one, we have drawn a construction that is perpendicular was drawn. Then if we do the same construction, if we draw a perpendicular line, then we can use for this triangle. Base is this and that's the height. and for this parallelogram base is this, and that's the height. So using the formula of area of triangle, 1 by 2 base into height, that is KL into 1 by 2 KL into TA. Then the area of parallelogram base into height, KL into TA. Then from first and second we can again prove that the area of triangle PKL is half the area of parallelogram KLQT. So you have two options for this theorem also. Now the last theorem of this first exercise, that is triangles standing on the same base and between the same parallel lines are equal in area. Again, drawing the figure first. We have taken base and parallel lines. Then drawing the two triangles. We have given two triangles, that is triangle PQR and triangle PQS are standing on the same base PQ and between the same parallel lines PQ and RS. We have to prove area of triangle PQR is equal to area of triangle PQS. For this we will do the construction. In construction we will draw a line parallel with PR, that is QA is parallel with PR. QA parallel PR is drawn. In proof, we will use both the earlier theorem which we have completed. First of all, that's the parallelogram now PQAR, and we have learned area of a triangle is half the area of parallelogram standing on the same base and between the same parallel line. So here in this figure, triangle PQR and parallelogram PQAR, area of triangle PQR is half the area of parallelogram PQAR. We can write earlier theorem, that is area of triangle is half the area of parallelogram. Instead of that, we can also use diagonal bisect of parallelogram. Diagonal bisects of parallelogram. For the second, this triangle and this parallelogram, area of triangle PQS equal half the area of parallelogram PQAR, that is area of a triangle is half the area of a parallelogram standing on the same base and between the same parallel lines. And from first and second, if RHS of both are equal, so LHS must be equal. PQ are equal area of triangle PQS, that is from statement first and second. With this, we have completed all the theorem of first exercise. Totally 3 this theorem and 3 more points. Total 6 points. Only maybe 6 points. Then some rules of geometry, properties of quadrilaterals and congruency. This type of things will be applied and all the question of this chapter can be done. Now I will write those points which we require more in this chapter after these 3 theorems. We have applied, first one was diagonal bisects of parallelogram. In figure, we have a parallelogram ABCD. And we have taken one of the diagonal AC. The diagonal bisects of parallelogram, it means we can write in many ways, like these two triangles areas are equal. We can write area of triangle ABC equal area of triangle ACD. We can write both of them are half of the whole parallelogram. Parallelogram ABCD. If we take the relation between parallelogram and this triangle, there will be two, one is half, another is double. If we require area of parallelogram ABCD, that will be 2 times the area of triangle ABC or area of triangle ACD. Then median bisects a triangle. Median bisects a triangle. I think all of you know what the median is. When we talk about the median, we must have a midpoint, a line segment joining the midpoint and the opposite vertex. Midpoint of the base and opposite vertex. Here in this figure, D is the midpoint of BC, then AD is a median. And same as earlier, bisected, so area of triangle ABD is equal to area of triangle ACD, and both will be equal to half the area of triangle ABC. Just simplifying that, we will get, if we require area of triangle ABC 2 times the area of triangle ABD and 2 times the area of triangle ACD. And what you have completed in class 9, these 2 theorems you must have to kept in your brain, that will be frequently used. That's the midpoint theorem and its converse. In midpoint theorem, what you have learned in class 9 is if A and B are the midpoints of the sides PQ and PR, then the relation between AB and PQR is, that is AB is parallel with QR and AB is half of QR. That relation will be required. And converse of midpoint theorem, again you have learned this in class 9, that is, if A is the midpoint and AB is parallel with QR, then B is midpoint of PR. That's the point we required. And then the area of triangles and quadrilaterals. But you have completed in class 9, you have also completed these things in mensuration. We required these things, then we can complete this exercise easily.